Hello everyone, this is Mr. Smith. Today we're going to talk about units, two main branches of units, not just the metric system versus the imperial system, but something even broader than that. Both those systems can kind of fall under something called the SI units. SI units for the international system of units, units that the whole world agrees to use as a base unit. And yes, many of those are metric systems, but a few of them aren't. And even within that, though, there are two main categories of units, base and derived. So base units are measured fairly directly. Length with a ruler, mass with electronic balance, temperature with a thermometer, time with a watch. A couple units you might not be familiar with is the brightness of something, named after a candle, candela, or electric current. And later in this year in chemistry, we're going to talk about a mole, how much material there is. So those are what's known as based units. They can be kind of directly measured without other calculations being involved. Other calculations being involved comes up with something called a derived unit. So here's some examples of derived units. You've heard the words for it, but perhaps don't recognize the units for it. Area, volume, frequency, density, and there's quite a few others. So where do these units come from? M squared, M cubed, inverse S, kilograms per meters cubed. Well, they come from other calculations. So for example, if I wanted to get an area of a box, let me draw a box. If I want to get the area of that and see what's in here, perhaps the area of your lawn or your living room, you're buying carpeting, you need the area of that. Well, you take the length times the width. Length times the width. And so the length and width are both versions of length, they're just different vocabs in terms of units. Now, the base unit for that could be meters, is meters. Perhaps it's miles, perhaps it's kilometers, perhaps it's inches or centimeters, but meters works well. And when you do dimensional analysis, we used to cross out units, but we can change the fact that length times width is the formula for area. So now we're doing meters times meters. So those don't cancel out. They actually end up meters squared, which again is what we have over here. So again, this could be inches squared or feet squared or kilometers squared or millimeters squared. But the idea that these units multiply up to get a derived unit. Again, a meter is a base unit. The area is a derived unit. Another one to talk about is volume. And again, you might know that volume is length. Let me get a pen. Length times width times height. When I say volume is length times width times height, I mean the volume of a cube. You could also think of that in terms of length times length times length. And so that has units as well. So meters, meters, meters. So if I'm going to multiply units together, meters times meters times meters, well, that gets me the derived unit of meters cubed. Again, they're not canceling out numerators and denominators. These are all the numerators. There's no fractions at all. So we end up with meters cubed. And so even though you can measure it directly with a graduated cylinder, the fact that the calculation of it in terms of areas of cylinders and cubes and rectangular prisms, that makes it a derived unit. So even some derived units can be measured directly using a piece of glass or using a piece of machinery. For us, we have a derived unit that comes from other units, so come from base units. So here's three more cubes, three different sizes. And the smallest one over here is a centimeters cubed. So this is a centimeter of a height, centimeter of a width, centimeter of a length. And so we have centimeters times centimeters times centimeters. And so that's what we end up here, cm times cm times cm. Well, that brings us to not only centimeters cubed, but the definition of a volume that we're kind of more familiar with, and that's a milliliter. So your very definition of a milliliter is how much of a liquid water can fill up this cube. Again, this cube has the dimensions of centimeters times centimeters times centimeters. I have a couple more cubes here. So if a centimeter cubed is a milliliter, well then what is a liter? If you notice here, it's a dm3. So dm3 as in dm cubed. So what is a dm? Well, if you remember the metric system, a decimeter is a little bit bigger than a centimeter. In fact, 10 times bigger than a centimeter. And so if you go to the numbers here, there's the lowercase d for a decimeter, 1/10 of a meter, while a centimeter is 1/100th of a meter. And so the decimeter is 10 times as big as the centimeters. But when you're multiplying that length times width times height, you get a 10 times bigger times a 10 times bigger times a 10 times bigger. Well, 10 times 10 times 10 is 1,000. And so what's 1,000 times bigger than a milliliter? A liter. And so here we have this middle cube of a decimeter times a decimeter times a decimeter. And that's the very definition of a liter. Again, a unit of volume we are more familiar with. Now, a meter cubed would be significantly bigger than any of those. Again, it would be 1,000 times bigger than the decimeter cube. So the other unit I wanted to talk about was density. Density is responsible for kind of cool looking pictures like these where things are floating and sinking, I guess, being suspended at different levels based upon their density. So density is also a derived unit. In fact, it's even derived from a derived unit. So I wanted to spend a moment to talk about that. Here's an equation you've had for quite some time. Density is mass per unit volume of a substance. Density, D, equals mass divided by volume. Now you can measure the mass, which is a base unit with electronic balance, and you can measure the volume, which is a derived unit. Could be a length times width times height if you're measuring the density of a block. You could also pour liquid into a graduated cylinder, which a cylinder has an equation, V equals pi r squared h. Or in this case, you read the numbers and figure out the volume of a liquid. And that gives us, which is, like I said, in itself a derived unit. Now you can divide the two and get yourself a density. And here's the base unit for density, kilograms per meters cubed. Again, those are this is the SI units of density. So it in itself is a derived unit coming from the base units of kilograms and meters cubed. These two are kind of more familiar, grams per centimeter cubed, or even kind of most familiar, grams per milliliter. And remember, those two are synonymous. Those two have the same meaning because a centimeter cube, also known as a cubic centimeter, is equal to a milliliter. And so there are quite a few derived units out there. For the most part, anytime you do a calculation, you end up with a derived unit. So thank you so much for your time, and I hope you've learned a bit about base units and derived units.